So here, what we're going to be looking at is finding the number of protons, neutrons, electrons for each of these things, basically filling in the gaps, and also writing the scientific notation, so the atomic notation if we need to as well, of these various things. The first one's been done for us. Now this is our lithium, all right? Our lithium, you can see its mass number's 7, its atomic number's 3. For the atomic number's 3, so's the protons, because the protons is the same as the atomic number. Neutrons is found between the difference between these two numbers, and the difference between 3 and 7 is 4. You've got to do some quick maths on this one. Now, electrons. Electrons is based around the charge of our atom. Now, you can see here it's got a positive charge. What that means is it must have one less electron than it does protons, because remember, protons are positive, neutrons are neutral, and electrons are negative. So therefore, overall, we must have one extra proton than electrons, which is why our electrons is 2 for this particular lithium ion. Let's have a look at the next one, which is calcium. Calcium, it's got an atomic number of 20, so the number of protons in that guy is 20. The difference between our two numbers here is our neutrons, so that's going to be 20. And how many electrons do we have? Well, we've got no charge, so therefore it's neutral, which means the positive must be equal to the negative, so therefore we must have 20 electrons as well. Let's look at the next one. This is sodium. All right, sodium has an atomic number of 11, which means its protons must be 11. Now we're already given the number of neutrons, which is 11 as well. So what does that mean? That our mass number for this particular sodium isotope must be equal to these two combined, which is going to be 22. Okay, and then this guy has no charge again, so therefore the protons must equal the electrons, which means it must be 11. Okay, moving on to oxygen. Oxygen here, its protons are 8. So the 8 is our protons because that's its atomic number. The difference between these two numbers make our neutrons, which is 8, and then we need to think about our charge. Our charge here is -2. What that means is it must have gained 2 electrons. It must have 2 more electrons than it does protons, because remember, electrons are negative, so therefore we have to have 2 extra ones here, so therefore it must have 10 electrons altogether. And because it's an ion. All right, let's look at the next one. We've got this guy here. Oh, this is interesting because we've got 15 protons. We don't know what the actual thing is, but we know that if it's got 15 protons, its atomic number must be 15. Okay, that's what its atomic number must be. Now, because the atomic number and the protons, that defines what the element actually is, I can look at my periodic table, which I don't actually have with me, but I know off by heart, that 15 is phosphorus. You're not to know that off by heart. You would look at your periodic table and look at what is atomic number 15. That's phosphorus. Okay, so therefore this symbol would be P. Now, the difference between these two would be our neutrons, which is going to be 16. And then, let's look at it. It's got 3 negative. If it's got 3 negative, it must have 3 extra electrons than it does protons. Let's move it down here so we can see it. So it must have 18 electrons because it's got a charge of -3. So therefore, we're finding our protons, neutrons, electrons for that. And we basically keep on going through until we finish this question sheet. There's going to be, you've got a link to these solutions, so you can actually go test that out. So good luck with doing this. This has been a video explaining how to find the protons, neutrons, electrons based around these particular things here.